Hello, we're at the University of New South Wales and I'm N J Wildberger. We're now in Chapter 2 of the Linear Algebra course, and this problem, problem 15, asks to find a vector which is perpendicular to two given vectors, the vector 1, 3, 2 and the vector minus 2, 0, 4. And what you need to know is the cross product. The cross product is the idea that tells us how to get a vector which is perpendicular to two given vectors. So let me remind you, recall that if we have two vectors, let's say a1, a2, a3, and another vector b1, b2, b3, then the cross product between them is a third vector which has the following form. The first coordinate is a2, b3 minus a3, b2. And the subsequent entries are just the same as this one, but with the indices rotated around. You can sometimes keep this little mnemonic in mind. 1 goes to 2, 2 goes to 3, 3 goes to 1. So the next one would be a3b1 minus a1b3, and then a1b2 minus a2b1. That's the cross product of these two vectors, and it has the property that it's perpendicular to both of them. In fact, if first vector, say, is in this direction, and the second vector is in this direction, then the cross product will be in a perpendicular direction, and the three vectors will form a right-handed system. Namely, if I take the three fingers of my right hand, thumb, first finger and second finger, and put thumb along the first vector, second finger along the second vector, then the third finger points in the direction of the cross product. So we say it's a right-handed system. Okay, so in this particular case, it's relatively straightforward to compute the cross product. So our solution is, we just take 1, 3, 2 cross minus 2, 0, 4, and we apply this, this rule. So the first entry is 3 times 4, I might write it up here, 3 times 4 minus 2 times 0. Then the next entry is 2 times minus 2 minus 1 times 4. And then the next one will be 1 times 0 minus 3 times minus 2. So what do we get when we evaluate that? 3 times 4 is 12, minus 0 is 12. 2 times minus 2 is minus 4, minus another 4 is minus 8. And then 1 times 0 is 0, minus 3 times minus 2 for a total of 6. And let's just check that this vector really is perpendicular to 1, 3, 2 and minus 2, 0, 4. How do we do that? We just take the dot product between two vectors. If the dot product between two vectors is 0, then they're perpendicular. So we can quickly check that we have got the right answer by taking the dot product of these two, which is 1 times 12 plus 3 times minus 8 plus 2 times 6. So 12 minus 24 plus 12, that is 0. So these two vectors are indeed perpendicular. And here again, take the dot product, we get minus 2 times 12 is minus 24. Plus 0 times minus 8, that's plus 0. And plus 4 times 6 is plus 24. So again, a total of 0. So yes, indeed, that's the answer. The answer is 12 minus 8, 6.